Hello everyone, welcome back to the next part of our Plotly 3D visualization series. In our previous video, we learned how to create interactive 3D scatter plots using the Iris dataset. We covered everything from plotting basic 3D points, customizing marker and layout, to drawing a path line for one of the species setosa. Today we are going to expand on that concept. In this video, we will learn how to filter our dataset by species and plot each group separately in a single 3D chart. So this will help us clearly compare three iris flower species, Setosa, versicolors and virginica. And just like before, we will use the iris dataset and continue in the same Jupyter notebook from our last video. So let's begin setting up our color map just like we did in the last video. We defined a color map that assign a specific color to each species. So we have already done this in our previous videos. So if you are following along from there, this part should look familiar. So we map this dictionary to a new column called color in our data frame so that each row carries its corresponding color value based on the species. So now we move on to the filtering our dataset by species. So what we are doing here is creating a three new subset of the dataset, one for each iris species by using df in square bracket df in a square bracket species equals to iris setosa. So here we are telling pandas to return only those rows where the species is setosa. So we repeat this for versicolor and virginica. So this step is essential because we want to plot each species separately using their own 3D scatter trace. Now let's build the actual 3D scatter plots for each of these filter dataset. So let's now look at how we build a 3D scatter trace for the first species, Setosa. We start by using the go.scattered 3D function. This is plotly function for plotting 3D scatter plots. We set the x, y and z parameter to sepal length, sepal width and petal length respectively using the Setosa only subset we created earlier. This tells Plotly exactly where to place each data points in 3D space. And the mode equals to markers indicate that we want individual points plotted rather than lines or any other shapes. Inside the marker dictionary, we define visual styling. So we use size equals to 6 to make each data points clearly visible without being too large. And we set color equals to blue to represent Setosa as a blue in our visualization. And finally, we use the name equals to Setosa parameter so that the legend will display the trace as a Setosa. So helping viewers easily identify which color corresponds to which species in the plot. So we repeat this same structure for the other two species. For versicolor, we use the filtered versicolor dataset. Assign the color green and label it accordingly. For Virginica, we do the same using the Virginica data. Set the color to red and name the trace Virginica. So these three traces, each carefully styled and labeled, are what we will combine in our final visualization. Now we combine all three traces and update our layout. So we use go.figure function and pass a list of three traces into the dataset into the data parameter. So this effectively overall all three species in our single 3D space. The update underscore layout functions is used to enhance the visualization. We set a descriptive title, define the axis label, under the Skin Dictionary, which is a specific to 3D charts. And adjust the figure size using height and width. Height equals to 700 and width equals to 1000. And finally, we run fig.show function to render the plot. Now let's run this code and observe the output. Once the chart is rendered, you will see the interactive 3D scatter plot where each species is plotted in its designated color: blue for Setosa, green for versicolor, and red for virginica. You can rotate this chart freely, zoom in, zoom out, and inspect it from different angles to better understand the distribution of the flower species. One particular use code features in the interactive legends in the top right corner of the chart. When you click on the species name, it hides or unhides the corresponding cluster. So this means if you want to focus only on Setosa or temporarily hide Virginica to reduce clutter, you can simply click their names. This interactivity is extremely helpful for exploring each species individually. Because we have separated and filtered each species into its own layer, the visual clarity is greatly improved. You will notice that Setosa form a very tight and distinct cluster, indicating how different it is in terms of its sepal and petal measurement. On the other hand, versicolor and virginica may appear more overlapping, which suggests they are more similar to each other. So this kind of 3D visualization help us gain insights that would be much harder to observe in 2D, especially when analyzing multidimensional relationship in real dataset. So that's it. In this video, we learned how to filter data by species using pandas, creating individually 3D scatter traces for each species, assign unique color and labels, combine all traces in one interactive 3D chart. So this filtering method makes our visualizations more organized and meaningful. So I hope this session was helpful to you. If you have any questions, feel free to ask in the comment below. Thanks for watching and see you in the next video.